All right, 9.3 on page 62. Real world problems. Graphing. All right, so you got to be on page 62 for this one because I am not going to go explain it all myself. You have to be following along in your book for it. So, Angela's driving to the Raccoon River. What a great name for a river, first of all. The distance in D miles after T hours given by D equals 40T. So I'm going to write that down. D equals 40T. Otherwise, we should remember that D is the dependent variable because it depends on what T is. Graph the relationship between D and T. Use 2 units on the horizontal axis to represent 1 hour and 2 units on the vertical axis to represent 20 miles. So they have, you have T here, D there. This is in hours, this is in miles, I believe. Yep. And then 2, 3, 4. So a graph, in 0 hours you go 0 miles. 1 hour you go 40 miles. You're going 40 miles for every hour. 80, 120, 160. It keeps on going up like that. So that's the first portion of it. A, it asks you to graph. It says, what type of graph is it? Well, it's a straight line. So if you make this one down here, you're always going to want to make the independent variable, or the top one. Independent variable is always going to be the top one. Independent variable down here, so time is going to be down there, which you see time is down there again. 1, 2, 3, 4. You have to actually label them when you're making a graph. So when you use the graph paper for the assignment, make sure you're labeling it. So 1, 2, 3, 4. And then here, did it specifically tell us how much? Yeah, it said 1 hour. It says 2 units on the horizontal axis to represent 1 hour. So 2 units, 1 hour, 2, 2, 2, 2. And then 2 units on the vertical axis to represent 20. So this should be 20, 40, so on and so forth. So 1 right there, that's 40, and then you're going to keep on seeing it go up. Draw a line through it. That's why it says it is a linear graph, because it looks like a line. It is not going to be curving all around. It's just a straight line. That's what makes it a linear graph. Then it says, how far did Angela drive in 3.5 hours? Well, if you look at the graph, you look halfway between 3 and 4. That's 3.5. Go straight up, and it meets at 140. So how far can she drive in 3.5 hours? 140 miles. At what speed is Angela driving? Well, we know speed is distance over time. Well, we already know that she goes 40 miles in 1 hour, so she's going 40 miles an hour. D, Angela has driven for 4 hours. If she drives for another hour at this speed, how far will she drive? Well, she's driven for 4 hours. If she drives for a 5th hour, 5 hours times 40 miles per hour, 5 times 40 is 200 miles. That's how far she's going to have driven. E, if Angela wants to drive at least 120 miles, how many will she need to drive? Express your answer in the form of an inequality in terms of T, where T stands for the number of hours. So we look at, she's going to drive at least 120 miles. This is where we see here. T, at least. When we hear the name at least, we remember from last section, at least is greater than or equal to. And how many hours will she need to drive? 3 hours. So T is greater than or equal to 3 hours, or greater than or equal to 3. Name the dependent and independent variables. I already talked about them. Independent variable is almost always, I'd say 90-95% of the time, it's this first variable here on top, because the independent variable, it doesn't depend on anything. Time is going to go up no matter what. But the hours, but how far you go, the miles do depend on how many hours there are. So your miles aren't going to go up no matter what. It depends on your hours and how long you're driving for. That's it. That's the whole section. You guys can work on guided practice. I think there's just, what, 1, 2? Guided practice 1 to 2. And then your assignment.